Hi there, the purpose of this video is designing and implementing a simple 4-floor elevator with SIMATIC Step 7. First, the project will be defined in details, then I'll explain my hardware, finally I'll implement the project and explain its program codes. Okay, let me define the 4-floor elevator project. This figure displays a practical view of my elevator system, which must be controlled by a PLC. The cabin is moved by a motor in two directions, up and down. When the PLC is run for the first time, the cabin should be moved to the first floor. The first sensor can detect whether the cabin has reached the first floor or not. After that, the elevator system can be used, and if any push button is pressed, the cabin will go to the selected floor. Wait 5 seconds, and then if there is another request, the cabin will go to another floor. Note that to update the cabin's position, the second sensor can be used. It produces a pulse by passing from each floor. For example, when the cabin moves upwards, each pulse of this sensor means the current position of the cabin has increased one floor. Also, 4 LEDs were used to indicate the current position of the cabin, and these two tables illustrate all input-output addresses of my PLC which will be used in this project. Alright, let's start the video by launching SIMATIC Manager software. As you know, using the wizard window, a new project can be created by selecting its CPU model, preferred language, project name, and finally, I need to click on Finish. But let me click on Cancel to create my project manually. Okay, SIMATIC Manager has opened my last project. It's my final 4-floor elevator project. Before to explain it, let me create a new project manually to explain how a PLC can be configured by SIMATIC Manager. Well, let me write a name for the new project and then click on OK. As you see, there is not any PLC. I'm going to use a SIMATIC S7-300 CPU, so I need to add a SIMATIC 300 station to my project. After that, I need to define my hardware, so I double-click on the hardware icon. Well, inside the OpenET window on the right side, under the SIMATIC 300, I can find and add my equipment. First, I need a simple rack. As you see, 11 modules can be added to a standard rack. The first row determines power supply type. Because I'm not using any of these power supplies of Siemens company, let me leave the first row. It doesn't matter the type of power supply to generate system data. Inside the second row, I have to specify my CPU model. I'm using a version of CPU 315 2DB. Okay, let's continue. The third row is used to determine the type of interface module. This module is used to extend our S7-300 station, but I don't have it, so let's go to the next rows. Well, from the fourth row, I should specify other modules which were installed beside my CPU. I'm using 2 digital inputs, 1 analog outputs, and then 2 digital outputs, and finally 1 analog input. Let me find and add them to the inserted rack. As you see, based on a simple rule, SIMATIC Manager has assigned these addresses to the inserted signal modules. In this project, I prefer to change the default addresses related to these two digital output modules. Okay, let's continue to add my last module. That's an analog input module. Alright, I've configured my hardware. Now let me click on the save icon. As you see, my CPU has been added to my project. As you know, this plug OB1 can be used to write my program. Note that the hardware information must be downloaded as well as the PLC program. So let me open the hardware configuration window and then click on this icon to generate system data inside my project. Now, after specifying my hardware, let me start the programming step. First, let me add OB100. This plug is executed only once, exactly after the PLC is turned on. Well, after OB100, my CPU will execute OB1 continuously as the main plug. Now, let me add a function. It will include the main part of my program to control the elevator system. It will be called by OB1. Okay, I want to use OB1, OB100, and SC1 to write my program. Now, let's continue the video with the final project. It includes my final program and hardware information. So let me close this window. Okay, as I mentioned before, this is my final project, which includes my final program and hardware settings. First, let me check the connection between my PLC and computer. So let's select Set PG and PC Interface under the Options menu. Well, I'm using MPI port of my PLC, so I need to select PC Adapter MPI. Now, if I click on the Accessible Nodes icon, I can see that my PLC is connected to my computer using its MPI port. Now let's download the whole project on my PLC. Before that, let me reset the CPU using its mini switch. Alright, the project has been loaded on my PLC successfully. Now let's test it and also explain its program. As I mentioned before, first my CPU will execute this block OB100 once time when it's turned on. So let me open it. Well, based on the program, my CPU will reset these memories which were used inside OB1 and FC1. I'll explain their programs later. Also, if the first sensor is inactive, this address Q0.7 will be enabled at the beginning to move the cabin to the first floor. Now, let me enable the monitoring option and then run my PLC to see its performance. Note that instead of these two sensors, I've used these two switches. As you see, because the first sensor is inactive, my PLC has enabled this output Q0.7 to move the cabin to the first floor. Remember, OB100 is executed only once time. After that, PLC executes OB1 continuously, so let me open OB1. As you see here, I have three networks. Right now, the cabin is moving down, and when it reaches the first floor, the first sensor will be enabled. This sensor has three tasks. First, it moves number 1 to this memory, then stops the cabin, and finally enables a bit of memory to indicate the elevator system is ready to be used. Note that this memory includes 16 bits, and only the first 4 bits will be used in this project to indicate the current position of the cabin. Also, this bit memory has been used in the test network to call FC1. It includes my main program to control the elevator system. For example, it uses these 4 LEDs to indicate the cabin position. Right now, the cabin is located at the first floor. Now let's open the function. Alright, my function includes 7 networks. The first one uses 4 SR instructions to store any request from the 4 push buttons on these 4 bits of memory. Note that these 4 bits have been used to indicate the cabin's position. Naturally, when the cabin is located at the first floor, the first push button cannot set this bit of memory. But if I press the other 3 push buttons, for example the first one, the related bit will be changed to true. Note that every time the cabin reaches the fourth floor, the storage request on M0.3 will be reset automatically. Right now, the cabin is located at the first floor, and my PLC has enabled Q0.6 to move up the cabin to the first floor. Now let's go to the second network. Remember, these 4 bits on this address determine the cabin's position. By receiving each pulse from the second sensor, if the cabin is moving up, these 4 bits will be shifted to the left side. And if the cabin is moving down, the 4 bits will be shifted to the right side. Inside the next network, I've used them to enable these 4 digital outputs which are connected to these 4 LEDs. Right now, the cabin is moving up, and by passing from each floor, this sensor produces a pulse. Let me use that. As you can see, the cabin position is increasing by receiving each pulse from the second sensor. Now the cabin has reached the fourth floor, and my PLC has stopped the cabin. Let's continue. The next 2 networks determine the cabin must be moved up or down, based on the current position and the storage requests on these memories, which were defined in the first network. Now the cabin is located at the fourth floor. If I press the first, second, or third push button, the cabin will need to be moved down. Let me press only the second push button. As you see now, based on this memory, the cabin needs to be moved down. Now let me explain the last 2 networks with similar program codes. Network 6 turns on Q0.6 to move up the cabin, and the next one is used to move down the cabin. Well, let me explain only the last network's logic without this contact of the first timer. Remember, the cabin is located at the 4th floor, and I pressed the second push button too, and based on the previous networks, the cabin needs to be moved down. Therefore, my program enabled Q0.7 to move down the cabin. Right now, the cabin should go to the 2nd floor. Let me select another floor, for example, the 1st floor, and then use the second sensor. Now, each pulse of the second sensor means the cabin position has decreased 1 floor. As you can see, when the cabin reaches to a selected floor, the cabin will be stopped 5 seconds, and then if there is any request for other floors, the cabin will go to selected floor. Alright, I hope this simple project using SIMATIC Manager is useful for you. Now, I wanna connect an HMI to my PLC to monitor the 4-floor elevator system. Okay, this is my design screen. Let me explain its main parts. First, these 4 buttons can be used to select each floor. These numbers illustrate the cabin's floor, and if you remember, the cabin should be stopped 5 seconds at each floor. During this time, the related door will be open on the HMI screen. Also, based on the cabin's floor, one of these 4 indicators will be green. Finally, these arrows display the direction of the cabin's movement. Alright, let me continue the video with this project in SIMATIC Manager, which was explained already. Note that I'm going to explain only added settings and program codes related to my HMI. Let me start with the hardware configuration. Okay, in my hardware configuration, I've enabled the second port of my CPU to make a connection between my PLC and HMI. Remember, the first one was connected to the SIMATIC Manager software installed on my computer. Let me double-click on the second port. As you see, a network was created before. Otherwise, you can click on New button to create a new network. Okay, any networks can be selected to see or change its settings. For example, this value was selected as the transmission rate in my network. Or my PLC address number is 2. Note that each device inside a network has a unique address. Now let me save the hardware settings and then explain all changes in my program codes. As you know, PLC starts its work from OB100. Let me open it. Inside this block, I only added this part to reset these memories which were used inside the other functions. As you know, after OB100, OB1 will be executed continuously. Let me open it. As you see, a new function, FC2, has been added to my previous program. It prepares some data which should be displayed on the HMI. Also, I've changed the first network FC1 a little. First, let's open FC2. As you see, the second function includes 2 networks. The first one stores the cabin's position, which is a number between 0 and 4 on this memory, MW30. This address was used inside my HMI to display the cabin's position. Well, inside the second network, these memories have been connected to these 4 doors on the HMI screen. For example, if the cabin reaches the second floor, it will be stopped 5 seconds by one of these 2 timers. So this bit of my PLC memory will be enabled when the cabin must be stopped 5 seconds at the second floor. Now let's open the first function, FC1. Okay, inside the first function, I've only added these 4 addresses below these 4 inputs. Note that I've connected these bits of my PLC memory to these 4 buttons on the HMI screen. So I can use the 4 buttons to call any fellow, like these 4 inputs which were tested already. Alright, I've explained all changes inside the SIMATIC Manager project. Now, let me run my PLC and test the project. After that, I'll tell you important points about my screen and also how a simple screen can be designed by PM Designer software. As you know, when I start my PLC, the cabin should go to the first floor in the beginning. If you remember, the first input detects whether the cabin reaches the first floor or not. Let me enable it. Now, the cabin is located on the first floor and the elevator system is ready to be used. Let me call the second failure using my push buttons, and also I can select the third failure, for example, using the design buttons on the screen. Now let me zoom in on my HMI screen because the PLC program was tested already. Alright, the cabin is located on the first floor, and if you remember, I selected the second and third floors, and now the cabin is moving up. Okay, the cabin has reached the third floor. Now let me count the other floors. As you see, now the cabin is moving down. First, it must go to the second and first floor, and then go to the fourth floor. Now inside the SIMATIC Manager software, let me open the second function, FC2, to see its relationship with the HMI screen. As I mentioned before, it just prepares some data which should be displayed on the HMI screen. Okay, let's continue. Well, the first network of the second function stores the cabin's position number on MW30, which was connected to these dynamic displays. Okay, the next network determines the first 5 seconds that the cabin must be stopped at each floor. Okay, I've tested my HMI screen, and now let me tell you important points about that. My HMI can be programmed by PM Designer software. First of all, I've connected these buttons to these addresses which were used to call a floor inside the first function FC1. Also, this numeric display, which can be added from here, is connected to this memory, MW30, which includes the cabin's position. These two arrows are connected to Q0.7 and Q0.6 to display the direction of the cabin's movement. As you know, a bit of memory has only two modes, on or off. As you see, I can determine color, text, or picture for each mode inside the Properties window. For example, I selected a black and green arrows to display the Q0.6 is on or off. Remember, this digital output moves up the cabin. Overall, other objects can be added into the screen and also can be connected to another. Now, let me create a simple project to explain how my HMI can be programmed and connected to my PLC from the first step. As you see, I need to write a name for my new project. After that, I'll determine my HMI model. Well, in this window, I'm going to create a link between my HMI and PLC. As you know, I'm using a S7-300 CPU of Siemens company. Now I can modify the created links parameters. For example, if you remember, inside the SIMATIC Manager software, I selected this transmission rate for my PLC whose address number was 2. Now if I click on the Finish icon, the new project will be created. Note that if I click on the link icon on the left side, the connection settings between my HMI and PLC can be adjusted. Also, I can use the internal memory of my HMI. Now, let me add a button. I wanna connect it to an internal memory of my HMI. Okay, let me change some graphical properties. Now let me add a bit lamp to my screen and connect it to the bit of my HMI memory which was used for the button. In consequence, this button will be able to turn on the inserted bit lamp because both of them have been connected to the same address. Well, to test the created link between my HMI and PLC, let me use a numeric display and then connect it to MW30 of my S7-300 PLC through the created link. Remember, MW30 indicates the cabin's position. Now let's compile the design screen and then transfer it to my HMI via its USB port. Okay, as you see, I can only set on the bit lamp using the button. Let me go to the PM Designer software and change the operation mode of the inserted button to momentary on. Now, again, let me compile and transfer the design screen. Okay, my HMI screen has been transferred. Let me test the button and bit lamp. Now let me change the cabin's position to check the created connection between my PLC and HMI. Alright, I added an HMI to the 4-floor elevator project. I hope you enjoyed this video. Thanks so much for watching.